Hi children, welcome to today's class on alternate segment theorem. This is the statement of the theorem. If a line touches a circle and from the point of contact a chord is drawn, the angle between the tangent and the chord are respectively equal to the angles in the alternate segments. Here the yellow region is the minor segment and the blue is the major segment. The angle formed in the yellow region, that is the minor segment area, will be equal to the angle formed in the major segment and vice versa. Before moving on to the actual proof, let's recollect some important fact which will make us the proof understand much better. First, angle inscribed in a semicircle is a right angle. That is, it will always be 90 degree. Am I right? Okay, let's move on. The second one is angle in the same segment are always equal, whether it may be major segment or minor segment. Next, sum of opposite angles of a cyclic quadrilateral is 180 degree. The last two may be very familiar to you, but it is important to recollect it at this point. What are complementary and supplementary angles? Complementary angles are two angles whose sum is 90 degree. While supplementary angles are two angles whose sum is 180 degree. The last one, sum of the angles of a triangle is always 180 degree. I think you enjoyed the visual proof for all these statements. Now let's move on to the actual proof. Now, what are we given? A circle with center O. The tangent AB touches the circle at P. PQ is a chord. What is to be proved? What is the construction to be made? I am not going to do that at present, but interestingly, I am going to move on to the proof first. You will understand why. As I don't know this angle, I assume it as theta. Now I construct the diameter PR. Now, what do you observe? RPB is a right angle. Also, we can say that these two angles are complementary angles. If one angle is theta, what will be the other angle? Yes, 90 minus theta. Now, I join QR and make it a triangle. Now what do you observe? RP is the diameter. So the angle inscribed in a semicircle is 90 degree. We know that sum of three angles in a triangle is 180 degree. Just now we have seen that. So if one angle is 90 and the other angle is 90 minus theta. What will be the third angle? Obviously, it will be theta only. Why? Because only when if it is theta, if you add all the three angles, you will get 180 degree. Now, I am going to take a point S in the major segment and join them to the chord P and verify whether that angle is also theta, since angle QPB in the minor segment is theta. If PQ is the chord and angle PRQ is the angle in the major segment, which is theta, then what will be the angle PSQ? It will also be theta. Why? Because angles in the same segment are always equal. Wow! Our first half of the proof is over. Now we don't need these two line segments. Next, let me take a point T in the minor segment and join it with the chord PQ. AB is a line segment. Angle QPB is theta. What will be the other angle? 180 minus theta, because they are supplementary angles. So, we have to prove angle T is also 180 minus theta. Very simple. What is angle S? It is theta. Then what will be angle T? It will be 180 minus theta. Why? Because sum of opposite angles of a cyclic quadrilateral is 180 degree. If one is theta, naturally the other should be 180 minus theta. Am I right? Now, very easy, isn't it? Some of you may have a doubt. Will I get full marks for this? Yes. Whatever may be the method you use, that doesn't matter. Ultimate aim is to prove it properly. We have done the right proof. Write with confidence and you will get full marks. Thank you, children. Catch you in another video.